All right, let's begin with that idea. And this idea of like converting equations is going to be a powerful one here. So we only had a couple pieces of equipment yesterday, right? And we'd like to bring them back to mind now. We'll use the exact same facts. We learned that x equals r cosine theta and y equals r sine theta. We also learned that x squared plus y squared equals r squared. But did we really need to learn those things? Well, they should in fact all be familiar, because what does this stuff remind you of? Do you remember like another time in your life where we might have written that xy was equal to r cosine, r sine? When was the last time you thought about that? Daniel? Vectors, right? And r could also be thought of as what? R could also be thought of as the magnitude. Yes, had imaginary bonus points to receive it. Right? Yeah. Now the only caveat here is that within the context of polar coordinates, we often treat r as being a negative number. Okay, like we just discussed. So that's a little bit of a difference. But generally, all the equipment, all the trigonometric equipment that you have, that you had at least at one point, you can bring to the table. There's nothing in that discussion, like for instance in the warm-up today, that should have really felt new. It's a new context maybe, but really like you deciding which trig function to use and you worrying about the quadrant, and all that should be kind of old hat that you're just re-traveling, right? You're just going down again. All right, so this is what the equipment you used as you converted coordinates last night in your homework. This is also the same equipment that we use to convert equations from rectangular to polar form, or from polar form to rectangular form. Let's just do the equation from your homework last night that we were just doing on the board over there. R equals 2 cosecant theta. And we're about to blow your mind, right? We could do it this way by observation, graph it, and then be like afterward, well, it seems like it's y equals 2 from like a graphical standpoint. But can we kind of algebraically convince ourselves of that using the same technology up here? Just for fun, I might do that. Just divide by cosecant on each side. What's on the left then? It's actually
r sine.
It's actually r sine theta equals 2. And r sine theta is also another name for Okay, have we fully convinced you that in fact this is the horizontal line y equals 2? It's just said in another way, isn't it? So there, that was an algebraic argument. We've sketched it and we're convinced from the sketch that this is the line y equals 2. And now algebraically we've shown that if this relationship always holds, that y equals r sine theta, then we can use that as a replacement in our algebra. So yeah, this is in fact the horizontal line y equals 2. Have you played with polar mode on your calculator at all yet? Okay. If you haven't yet, you're welcome to, I'm inviting you now to do it. You can graph this line on your calculator and see how it goes. You'll go to, on your calculator, you'll go to function, mode, and then instead of function, you'll go over to polar mode. And then if you want to type this into y1, it won't be y1 anymore, it'll be r1. Now when you hit your xt theta n button, it'll be a theta. It just knows what you want. And you can type in this case, 2 divided by sine of theta, right? And you'll get a line, a horizontal line y equals 2. When you're going to the window, just like in parametric mode, you have your normal x and y min and max. But you also have like a theta now. Just like in parametric mode, you had like t mins and maxes for the parameter. Here, you also have control over what theta's min and max will be. So. So feel free to plot that line. And when you're ready, plot this one too and tell me what you see. 4 cosine theta. You might think, oh, that's a line too. Well, careful, it's not quite.
Oh, because it's going up and down.
No, I don't know. I think you might be surprised to see what you find there. What do you see?
Is that because you're not dividing it by?
Yeah, I mean, it's algebraically, it's not the same thing. Do you see what I see? You can do zoom square if you're not convinced, but what do you think it is? What is it? That's what I said. If you zoom square, you'll see it for real in its glory. Right? Zoom square just ensures that your x and y axis are scaled in proportion to one another. So, what is that? It's a circle, yeah. So now we're out to prove it. Let's do some algebra to convince ourselves that that's the case. You should have your min be lower than your x.
It's like it's equal to x squared plus y squared equals r. Wait.
That's a beautiful idea. I think you should, now your goals in life should be to explain why that happened. Yeah, because I think we can, actually. All right, are you ready to algebraically show that it's a circle? Let's do it.
With that, you like x squared plus y squared equals y with y squared is the same dimension. Parallel. Why is that?
Wait, what?
Like, is there a parallel with like x squared plus y squared equals r squared?
Yeah. We were going to use the equation of the Cartesian coordinates for a circle is hopefully what we'll get, right, in the end. And you've done a graph of a circle in your life before, right? So I think we'll recognize it when we see it. All right. So I hope we'll recognize it when we see it. I don't know. Does anyone have a first step algebraically here? Now we're thinking about it, not graphically. Forget the graph for a second, even though that was fun. Noah, you have an idea for us?
This could be wrong, but multiply by r.
Don't ever start things with this could be wrong. Have some confidence. That's a great idea. Why, for those who maybe didn't see that immediately, can you sleuth inside of Noah's head and realize why he's motivated to do that? Not just that he did it and that it works, but why is he doing that? What do you see that you like?
You want to get it like the other. Oh.
I want to see stuff from the last slide up here, don't I? I want to see an r squared. And I love seeing an r cosine theta. I love seeing both of those things. So I want to do whatever it takes to make those things appear.
Can you just...
What's r squared then? What's r squared?
The square root. Wait. Just take the square root of the other.
Well, what is r squared? We can say it more simply than that. It's just... Yeah, it's x squared plus y squared. Thank you, Kate. That's what r squared is. And what's r cosine theta? That's also known as r cosine theta. It's also known as x. So in fact, you might not believe it, but in fact we're done. I mean, we have actually converted it to rectangular coordinates. There's no more r and theta. There's only x's and y's. But just for the satisfaction of our audience here today, let's go further, okay? Why did I leave a space there? What'd you say? Huh? Yeah, what'd you say?
You're gonna extend. You're gonna make it a.
I'm gonna make it a yeah. I'm gonna complete the square. Yeah, I'm gonna. So what completes the square here? Yeah, you're gonna make it a with a 2 and. Yeah, good. Yeah. You're having all the right thoughts. I hear you. Okay. So then I think we can convince ourselves fully. Is this what you expected? Is this a circle of radius 2, centered at 2, 0? Yeah. That does confirm the picture that I saw. So let me just be clear. If they ask this, if this is being asked, then this is a fine solution right here, right? But if you want to know, you might want to do this just for fun. Okay.
Wait, where'd you get the 0 before?
I started by showing you this. I just had moved this over. And so there was a 0 on the right side. And then I decided just for fun to add 4 to both sides. Yeah, to complete the square. Alright, see if you can run this logic in reverse. I've got something that is a circle again, it looks like, yeah, in rectangular coordinates, and now I'd like to go back to polar coordinates. Yeah, so try that one. Matthew, while we're working.
I just wanted to ask about the two cosecant theta.
Good.
Isn't, so cosecant theta is 1 over sine theta.
Correct.
So wouldn't the value sometimes be negative?
Yeah, the R value will be negative. So that's what we were saying is that, like, for instance, when theta is 3 pi over 2,
It would be negative.
you get negative 2. So when you're pointed down, your R value is negative 2. So where is the point 3 pi over, where is the point negative 2, comma 3 pi over 2 in polar coordinates? That means go this way, and then do what? Walk backwards 2. So actually you still always land on that line. But you're right, absolutely. R could be positive or negative in that equation. Absolutely. Yeah. How'd you do?
On what?
This.
Oh, no, I'm just like, I'm not confused on anything, but I'm just confused in general about something that I don't know about, you know?
You have so many questions
When you
you don't
feel
know
like
answers.
you're missing something, but you can't really tell what it is. Yeah.
I can't help you.
Yeah, sorry. Sorry.
Wait.
You got this.
Expanding it is a great idea, sure. I'll do that. Is that what you guys are doing? Alright, for those who expand this out, tell me what to do. Start by expanding down.
Oh. R squared equals 6 R times theta.
Okay, I'm ready. Who wants to tell me what to do here? I'd like to, again, I want to think about getting our things I like. What do I want to see here? This time I want to, like, use the same technology but going backwards, right? We only have a couple tricks here. Yeah, Kate. Okay, I'll do whatever you say. Alright, so that comes here. That comes here. What else do you want?
And then the other side, do 8x minus 6y, and that would
Did you say negative 8x and 6y? And what about the numbers?
they cancel out.
Oh.
It would be minus 0.2.
Got it. Those go away. So I think we've done it, right? What's next then? What's x squared plus y squared? Do you see where she's going with this? R squared. Oh my. Equals negative 8 times r cosine plus 6 r sine theta. And what other thing might you want to try to do at least? I don't know. You might want to divide r out if you want to try and write this as a single function of r. So this one is convenient because this is a circle that just happens to go through the origin. Dealing with circles that don't go through the origin, it might be a little trickier. I don't know. But by the way, one other thing, if you wanted to write this as a single cosine function, could you? We'll leave it here, but we'll leave it right here. Do you remember doing that? Like the a sine x plus b cosine x, how do you get that into the form c times cosine x minus d? Does that ring a bell? One could do that, but I think we'll just refrain. But I just want to let you know that that is possible if you wanted to say that. Nah. All right, let's. For you, Maddie.
Just for me. Okay.
Are you okay with my term, rectangular coordinates? Does that mean, do you understand what I mean by that? Rectangular is a good word for it. Cartesian coordinates is a good way to say it. Yeah. No, that'd be like a point. This is an equation. This is like r of theta. This is a function. You type in your calculator in R1, right? You can see the circle with your very eyes. -8 cosine of theta. All right, let's try converting something from polar form to rectangular form. This isn't quite so trivial. All right, are you ready to fill up a screen with some math here? Okay. I want to make sure one thing to highlight here is that some things that are very pretty in polar coordinates are very messy to write in rectangular form. In fact, sometimes it's not even very easy or possible even. This one is possible. It's just a little messy. So we're gonna go for it. Let me suggest the first move. And the reason this seems like, why is that messy? That seems so nice. Well, it's because of the 3 theta, right? Like what we like, we've already talked about it. What we like to see are cosines and sines of just theta. But that's okay. I think I know how to write this in terms of cosines and sines of just theta. Do you?
Oh
no. Is that a groan of delight? You celebrating over the fact that we get to remember our trig identity? Right now, I'm interested in the cosine sum formula, and I'd love to hear someone tell it to me. So I'm looking for a hand. Who's got the cosine sum formula? Alex, go.
Wait, cosine sum.
Yeah, what's the cosine of a plus b? Or in this case, if you want to say cosine of 2 theta plus theta.
Oh wait, no, JK, I give up.
Cheater, you're looking at your notes.
Wait, I still have it.
Maddie's looking at your notes too. All of you are cheaters.
Oh wait,
Never
isn't
said
it like
you couldn't do a
sine
source.
I didn't say that. Noah, go ahead.
All right. For this one, cosine 2 theta times cosine theta minus sine 2 theta sine theta.
I mean, I'll give you points for getting that so quickly wherever it was in your notes, I guess. That's pretty good. Pretty good. Yeah, all right, so here we go. 6 cosine of 2 theta cosine theta minus sine sine. Cosine minus sine sine. Okay, but that's not it.
Wait,
There's more.
is that like sine?
What's the cosine double angle formula? Someone. Who's my hand? Cosine double angle formula. Steven knows. Go ahead.
Wait, no. Wait,
Cosine double angle. That's what's the cosine of 2 theta?
There are different ways to write it.
There are different ways to write it. Okay. Okay. And someone else has sine of 2 theta for me. Isabel, go ahead. Yeah. I think we thought about that one recently, didn't we? All right, and then I want you to multiply that out and think hard about what are we going to do next, and why was that helpful? Will do trade for. Sure, it says that. Okay. I'll multiply it out too here. What do we get? 6 cosine cubed? Whoa. Minus 6. Okay, I'm ready to hear from you here. What do I do next? I mean, that was fun, but was it helpful? What do we need? I mean, the thing I'm even more excited about than seeing cosines and sines of just theta is seeing r cosine theta or r sine theta. So if you want something in life, then make it happen, right? So would you like this to be instead of a cosine theta an r cosine theta? Wouldn't you like that to be the case?
Oh, snap, these are the things.
Wouldn't you like that to be true? I'm here for you today. I can make that happen. Oh wait, what's the consequence? So what did I just do to that thing? I just multiplied this expression by what? R cubed, didn't I? If I'm going to multiply that by r cubed, then I need to multiply everything by r cubed, yes? Now, multiplying this by r cubed is kind of nice and fun too, right? I'll multiply r squared of that by this maybe. And the other r of it by that. Okay, then just stare at that for a second because the next move is the fun part. But I want to make sure everyone's following. Is that good? Is that cool? You like it? We multiplied by r cubed everywhere. Just to make sure you understand that. Okay. And then, yeah, why have I written it in the way I've written it, and why have we done what we did? Because what are we going to go through in right now? What do you see, Alvin? Yeah, so what is this?
X squared plus y.
Why don't you just shout it out all the time, Dustin? That's correct though, good job. What is it? X squared plus y squared squared. 6. Elvin, get it for me here.
X cubed.
Good. Good. You might be like, really? You're going to put a box around that? Yeah, I am. That's it. Didn't we do it? I mean, we converted it to rectangular coordinates. Were you expecting it to be something nice?
Yeah.
Sorry, it's not really. But once you graph that in polar coordinates, you'll see why.
Wait, should we pull up?
It's not anything that you already have a name for. In fact, it's beautiful. In fact, we'll do some more of them tomorrow. And you may have just... Yeah, right? It's fun looking. Definitely not... Right?
This makes me feel uncomfortable.
Yeah.
Why keep it in that form? Why wouldn't you want to plug an X or like
What's that?
wouldn't you want to plug an X?
I mean, you could pull out an X or 6 or something, but you can't, if you're trying to solve for Y, you can't do that there.